So, welcome back. When we met last time, what we were talking about was we were talking about energy efficiency. We talked about energy efficiency as a parameter, and where we left was that energy efficiency was kind of a service-based model is what we talked about. And what I told you is that I'll start with the term called energy intensity in the next class, and that how energy intensity can be a very misleading term. So, energy intensity in a way you can take as a output based metric. So, it is basically a term which is used more for comparison rather than watching into what is the absolute reduction in energy uses. So, in terms of pure definition, it says that how much energy is consumed per unit of economy or per unit of physical output. It could be in terms of per unit of any economic output that we kind of measure this unit into it. What is the purpose? What is the purpose is to compare between across sectors, that which sector is more energy intense, which sector is less energy intense, which economy is more energy intense, which economy is less energy intense. So while there are some advantages to it, as you can imagine that there are some advantages with respect to when we are trying to compare apple to apple, when the geographical context are same, when everything else is same, it could be a good way to kind of a compare if there are some inefficiencies in the system, or there are some overconsumption in the system, or system is not working as effectively as it should. It becomes a kind of a useful indicator for that thing. But it is talking about energy use per unit of economic thing rather than absolute use. So, that way it can be very misleading term, and also it may reflect structural change. It may talk about economical composition, it may talk about activity level. Energy intensity could be very different. So, for example, energy intensity of a rural setup could be very different from energy intensity of a urban setup which is highly industrial in nature, because there the energy would be needed to run some of the utilities which are needed for those industries, for some of those services which are needed in urban style compared to a rural setup. So, while we cannot simply say that while per capita uses could be different, people in both places might be using similar kind of energy also, but in one place it may look higher just because it has some a lot of other activities also. So, we cannot really compare two things without having the same kind of a context, and also it has to have lot more data around it before we can make some meaningful kind of a comparisons around it. But also what you need to understand is that it doesn't mean always in improvement in terms of efficiency. It could be more terms that could be hidden behind it when we are talking about energy intensity as a parameter. So, overall energy intensity is the output indicator. It's not a control variable. It doesn't control anything, because it can be changed because of many other parameters, and I will show you in next few slides. Just before I move there are some common misinterpretation on policy. So, that's sorry for this very heavy slide, but just try to be with me on this slide. So, there is a misnomer then that falling energy oblique GDP is it means the efficiency is improving. No, that's a wrong notion to have, because as I said in the last slide also, there could be multiple reasons because of which energy per unit of GDP might be reducing. A very simple thing could be that there is a structural economic shift, that we have moved from manufacturing based economy to service based economy. So, we have just reduced, we have kind of kept the same GDP, but since manufacturing industry needs more energy to produce the amount of money compared to service based industry. So, suddenly things will look very different, but it didn't mean that society or the nation or the city has become more efficient. It is just that it has shifted from one type of economic activity to other kind of economic activity. We may outsource a lot of energy intensive products also. For example, when US shifted a lot of its manufacturing from US to China, it didn't mean the society became more energy efficient, or the energy intensity of the society reduced in absolute terms. They just shifted their energy intensive product from their own country to a third world country. It has a lot of hidden things behind it. So, we need to just be careful around that. It doesn't mean that efficiency is improving. Cross country energy intensity comparison reveals efficiency rankings. Again a misnomer, because the economic setup, the rural urban breakup, the industrial structure, the transport modes, lot of things can be different from one country to another country. So, it is not in absolute terms that we can compare two economies or two countries just by energy intensity as a parameter. Again, this needs to be put in the right context. Energy intensity can be used as a policy target. Again, a very misnomer target to have, because it can lead to a lot of manipulation. So, you can keep on increasing your GDP, and your energy intensity may look to be reducing, because it will not obviously reduce, it will not obviously increase linearly with GDP. So it will look like that your energy intensity is reducing, but actually it's a misnomer. So we need to be careful when we are saying that this could be simply a policy target. Policy target, something which could be more measurable or more controllable. Actually, it could lead to like it can really be meaningful only when it is leading to genuine efficiency improvement in end use technology and systems. But if it is not being done, the data can be really hidden. It could be really an Excel sheet kind of an exercise, which could lead to nowhere. And also the another misnomer is that lower energy intensity would mean lower emissions. Again, a misnomer. It doesn't talk about how energy is produced. It is only talking about that we need less amount of energy per unit of GDP. It doesn't talk about that how that energy is produced. Since we don't have that, we cannot say that lower energy intensity would mean in terms of lower emissions. So just be careful about these policy catch which are there around energy intensity, and that's why energy intensity is very misleading from lot of perspective. So where energy intensity can mislead. So as I said that what drives changes in energy intensity? Energy intensity can be changed because of efficiency. It can also be changed because of behavior. It can also change because of structure. There could be multiple reasons because of which energy intensity can change, and it can be, if you talk in terms of efficiency, it could be technological improvement to give the same amount of service with lesser amount of energy. As we have already talked in terms of energy efficiency, we have talked about it. High efficiency motors, better lighting technology, better thermal pumps. A lot of things can happen around it. Behavioral changes can also lead to it, that how people uses energy, how firms uses energy also. So it could lead to higher appliances use, lifestyle changes, reduced travel amounts, like during COVID what happened. So it could be really a behavior, forced behavior or inculcated behavior which can lead to these kind of changes. So there is the thing that is hidden behind that also. There could be some structure changes also, like as I already mentioned that the GDP might be changing from a manufacturing based GDP to a service based GDP, which can again lead to a situation where the energy per unit of GDP will suddenly start to look lesser, but that doesn't mean that our efficiency went up. Any of our services, like our grid became more efficient, or suddenly people are more energy efficient in terms of their use and all those things. That may not be the fact. So observed changes in energy intensity are dominated by structure and behavior and not efficiency alone. So we need to be really careful when we talk about energy intensity as a parameter, that energy intensity as a parameter can lead to a situation where it can really mislead if you start linking it to efficiency. If you start linking it to efficiency directly, it can really be misleading. Where it can be a valid proxy for efficiency. So if you really need to use intensity as a valid proxy for efficiency, you need to be careful about few things. One is that there has to be a high level of disaggregation. Don't look at it as a cumulative number. Disintegrate this into smaller parts. Compare apple to apple. Compare same situation to same situation. When you are comparing between two industries also, those industries should be of similar nature. Those industries should be serving to the same sector or same subsector. They should be using similar kind of technologies to begin with. Only then you can kind of start comparing that at that level, that energy intensity can be a meaningful parameter to compare at that level. Aggregated, as soon as you start aggregating a few things, as soon as you start aggregating at a GDP level and start looking at an aggregated GDP level, it will hide sector specific dynamics, it would hide sector some specific details around it. You need to have stable behavior patterns. So the levels and demand of service should remain constant between the two entities that you are comparing. Otherwise, one set of society or one part of the entity which you are comparing could have very different behavioral aspect compared to the other entity that you are comparing with. So which could lead to this intensity shift, which may not be factual, which could be hidden behind this change of behavior. So you really want to do this, so they could have similar kind of behavior. They should have controlled structural effects also, like, so economy should not be changing very quickly. Even if it is changing, the changes should be pretty well in control, or they should be pretty well known that why these changes are happening, and we should be able to disintegrate this data in the right fashion to come with the right indicators around it. So, and at a national level, these conditions are very difficult to meet. So that's why at a national level, putting energy intensity as a single parameter can be highly misleading from that perspective. So, but overall, without disaggregation, without controls, energy intensity is not equal to energy efficiency. So So that's a misnomer which a lot of students or a lot of researchers also carry in their mind, that they use these terms interchangeably. Be aware of that these terms are not interchangeable if the context is not clear. If the context is not same, don't use these terms interchangeably. Energy intensity has a very different kind of a meaning, energy efficiency has a very different kind of meaning. Why aggregated energy efficiency is a probability term? Like, try to understand that GDP is not a uniform output. Rupees 1 of GDP from steel production is not compared to Rupees 1 of IT services, because look at the amount of energy which IT service uses per unit of rupee generation versus the amount of energy which industry uses per unit of rupee generated. If you just compare this as a number, each sector will behave differently. Sector requirement will differ fundamentally. So as a unified concept, is a very difficult concept to kind of compare, and then it would mean that you will not be comparing apple to apple, you will be comparing apple to oranges. And once you start aggregating, what you will do is that even if one sector is behaving better, the number of that sector will be will kind of overshadow what inefficiencies might be creeping into other sectors. Because if you start looking at a cumulative level, and I'll show you some data as kind of go along, but it can really start getting hidden behind some of these numbers, and very difficult for you to disintegrate and then put your policies around that specific sector if you're trying to change something in that specific sector, because that specific sector performance might be very well hidden by some other sector which might be overshadowing or kind of plateauing that the sector that you're talking about. So aggregated indicators obscure technology level performance, and that's why when we continue our discussion of efficiency going forward, we will have to really go into sectorial analysis to really understand that how things are evolving and how things are changing. Energy per unit of GDP, it's a useful indicator, but a poor explanation. Already talked about this. What it does well though is that it tracks long-term macro trends well. It talks about that how I am evolving as an economy on a whole, how I am evolving as a country, at a broader, very macro level, how I am evolving. But it also enables cross-country comparisons, but with some caution, because then we need to see the context is same. We need to see that we are talking with the same kind of similar kind of countries. We are talking about similar kind of geographies. Or we understand the kind of differences that we are talking about here. What it does poorly is that it cannot explain that why energy usage has changed. Like, because we have not gone into sectoral analysis here, it cannot isolate technology, it cannot isolate behavior, it cannot isolate policy effects. So it's a very poor indicator from that perspective. So overall, aggregate energy intensity often disguises more than it reveals, and that's why it's a parameter which should be avoided to be used in a real scientific comparison mode. If in a scientific comparison mode, it's better to use terms like energy efficiency or some other specific terminologies around it. I think I've spent time on this, so but just to kind of complete is that efficiency comparison across products also can be misleading, because what can happen is that different products deliver different kind of energy services, and it will all depend upon that what kind of physical transformation is happening, what are the thermodynamical constraints around it, what are the process requirements. For example, 1 unit of production of steel versus 1 unit of production of ethanol would require very different energy thing, because steel would require very high temperature material transformation, while ethanol is more of a chemical reaction in which the chemical changes also lead to some kind of a thermodynamical changes, which needs lesser outside energy to be put in the system to make this transformation. So it can really lead to some false conclusion, which can lead to a situation where we could be comparing things on a very different wrong level, right? But having said it, since it's a good macro indicator, so some of the leading reports do track it because they want to see that what is happening at a macro level. But as a researcher, what I try to tell you is that just be careful on how you are using this as an indicator. But just to give you a perspective, what is happening in the world is that primary energy intensity, there has been annual changes which has been observed, because obviously countries has been under this pressure of reducing their energy consumption per unit of GDP. So there has been some improvement around it. So these are numbers which are kind of cumulative number for that block of the year, and then there has been, these are numbers which are more on a year to year changes basis. So what you can see that on year to year basis also energy intensity is improving. So energy intensity is a parameter which is on a positive trend. So countries overall are needing less amount of energy to generate same amount of money, which is a positive indicator. What we are seeing is that COP28 has kind of is talking about doubling the target compared to 2025 estimated numbers. So that's a more aggressive target which geographies are taking. If you start looking into that, how it has been performing, since it has been performing, but why the energy consumption is going up is because value added services has kind of gone up. More and more services are getting added to the whole structure, and that's why energy intensity, as I said again earlier also, could be misleading as a normal, because then we are not talking about absolute energy consumption overall, because then we start looking at global industry sector energy intensity changes. That has been positive because companies have worked towards it, but overall, since more services has been added to the whole industrial sector, the overall energy consumption actually has gone up. So it is not that overall energy consumption has gone down, actually overall energy consumption has gone up. So you need to be a bit careful about if you use as an indicator, but this is at least one indicator which has seen some traction of late. In terms of comparing it with respect to GDP and total energy supply, if you compare it, what you see is again on a year to year basis, it is a parameter which is still showing to be a kind of a positive trend. However, when you start comparing one economy to another, one country to another, what you will see is that not all countries have kind of changed or evolved in a similar manner on year basis. Some countries have shown to be doing much more aggressive earlier, and which their aggression has kind of reduced of late. So look at this green dot talks about 2010 decade, this yellow talks about 19 to 25, purple color is 24, 25 kind of a thing. So look at Europe, for example. They were doing much higher aggressive, or Europe or Western world on the energy intensity side, but since maybe they have exhausted a lot of their resources already on that, or maybe some low hanging fruits has already been handled. So their energy intensity was lesser this year, while economies like India continues to do better on this. China has been an interesting story where you saw a dip and now again it has kind of catching up. So again, you have to really use this number in the right context, because how the country has evolved during that period, how the country has changed its economy in that period, because this is again a parameter which is with respect to energy per GDP. So it is not just energy, it is energy plus GDP. So it will also depend a lot on how your GDP has done during that phase. So since GDP might be doing too well, so suddenly you will see energy by GDP number improvement to be good, but you need to really look at this number with that context in mind. So, but overall, if you look at that, many countries are exhibiting declining energy intensity. As I have shown that energy intensity as a parameter is declining across globe, but underlying causes may differ very widely, because it will depend upon sectors that the countries deals in. It depends upon the kind of GDP growth that country is seeing. That for Europe, for example, or Western world, which is kind of saturating on the GDP growth, there the energy intensity number changes will be much more difficult to achieve now compared to growing economies like Brazil or India or Indonesia, for example, where GDP is growing so fast that energy oblique GDP number improvement may look better year on year. And then it is a social structure which could be leading to it. So there are a lot of other parameters which could be leading to this kind of changes. So you need to really be careful about this kind of changes. And overall, I think I've already talked about this earlier, but just to reiterate, intensity reduction does not mean decarbonization. It does not mean energy efficiency has improved, and it doesn't mean that decarbonization is happening. It is only efficiency is only one contributor, and you need to be careful when you're talking about that as a parameter overall, right? Let us look India as a number. When you start looking at India as a number, India has been an interesting story that in India, industry progress, especially looking at the industry progress number, India industry energy intensity number dropped to nearly 0 compared to 1% earlier, because India has not been able to spend so much on the technology side of this industrial side so much. But while you look at China, China has been able to spend a lot more money or a lot more resources around their industrial sector. So that has looked positive. While US is an interesting story that they have gone negative into their energy intensity improvement, and their kind of energy intensity improvement has gone down because they are trying to pull back some of the manufacturing back to their own country. So it has kind of gone into the other side. So really from a contextual perspective, you need to really understand that what is happening in the context when you start comparing some of these numbers. But if you start looking into the how these pledges are taking place and how India is talking about future energy investment, India is betting a lot on end use changes going forward with respect to the changes compared to 2024. If you compare a couple of scenarios with respect to the changes in future with respect to pledges around the various scenarios in net zero emissions by 2050 or by 2070 or whatever we are talking about, energy intensity or overall changes in energy in demand sector side is something which India is betting a lot on. So India will continue to invest on these lines, and India is putting a lot of emphasis on this as a parameter. So overall, if we look at it, while industrial sector has not done so well for India so far, India's energy intensity has declined over last 2 decades. Contributing factors has been structural transformation of economy. Economy has been growing. Economy has been growing faster than the energy uses, which has led to this energy intensity getting reduced. And also, some of you may already know that India has taken a target that by 2030, compared to 2005, from an energy intensity perspective, it will have 40% reduction. So that's a big target which India has taken from an energy intensity perspective, that India will reduce energy intensity. So while many researchers claim that this is primarily around in India is betting around GDP growth than the energy efficiency side of it, but as you can imagine, India has to play on both sides. And again, I'm not talking about renewable energy integration here. I'm talking about energy intensity, energy per unit of GDP. India has taken an aggressive target on that line, and India has worked on structural transformation of the economy around it, because what has happened is India has become very heavy service based economy. And as I showed you on a couple of slides back, that a service based economy usually have higher GDP or significantly lower amount of energy per unit of GDP. And since this structure is changing a lot, that's why India has done well on this overall side of energy intensity side of it. Gradual adoption of efficient technology, it has happened in certain sectors. I'll show you that through some numbers. India has also kind of put emphasis on this adoption of new technology as a structural method. So India has done well on that side, and there have been some policy driven interventions which I'll kind of tell you in next couple of slides. But absolute energy consumption of India continues to rise, as we all know, because still India is growing as an economy. So its GDP growth is faster compared to energy growth. If it is one arrow, GDP growth has been kind of a 2-arrow thing, but it is not that energy is not growing. Energy is still growing, and emission pressure still remains strong in India, because India still has to develop as an economy on a whole, because India cannot afford to degrow. India cannot afford to slow down its growth, because it still have a lot of people who are below poverty line. So you need to understand this in the context that India, from an energy intensity perspective, it has done well. What it has not been able to do so far is that it has not been able to do so well on the energy intensity of on the industrial side. So if you really go into understanding that, as I've talked earlier also, that from an Indian perspective, we need sector specific policy. And why we need sector specific policies, as I showed earlier also in the graph to you, that if you really want to disintegrate, you need to talk about non-aggregated level for this energy intensity as a whole. You need to talk sector wise. You need to have policy which is more sector wise policy. Only then you can talk about a situation where you can really see that has that specific sector improved or not improved. So what you need is basically policy making would require sector specific baselining, and technology level benchmarking is what will be needed as a country, which India realized. Aggregate intensity will hide inefficient subsector, and I'll show you through some data what is happening. So what India came up with is that India came up with the policy of, for all sectors, under a policy called PAT policy. It is perform, achieve and trade framework was set, where efficiency targets were set for each sector specifically. Each sectors were looked at specifically, each sector was studied, and by studying each sector, a target was given to each sector, and it kind of what it did is that it kind of avoided reliance on economic wide averages, and also kind of anchors efficiency in physical performance is what was targeted under this, and I'll show you data for this. So this kind of motivated India to talk about NMEEE and PAT framework. So these two frameworks kind of came up in India for measuring this energy intensity and energy efficiency side. So I'll not spend much time on NMEEE, but just to help you understand that this was India's response to limitation on aggregated energy intensity based climate and energy planning. This was India's response. India came up with this framework in 2008, where they were talking about energy efficiency planning, they were talking about PET framework, they were talking about market transformation of energy efficiency, and they were talking about framework for energy efficient economic development. Is kind of 4 verticals India was talking about. It was designed to unlock 74,000 crores worth of energy efficiency opportunities, and multiple 4 frameworks kind of was built under this for different aspects of economic and technology intervention and sectoral intervention which was done. And overall it was again India was trying to go around the line of the word theme of IEA. What IEA talks about is that it is kind of a first fuel. It may reduce emission, it may bring in capital intensity, and system cost would be needed for India's long-term climate and global security goals, which India was targeting around it. So under this, as I already told you, that a PET scheme was developed in India, and PET scheme was rolled out, and it was in which it was 3 things were talked about, that market-linked efficiency as a decarbonization lever, proven emission and investment impact at scale, and basically talked in terms of energy industrial transition. It was talked about 13 sectors were kind of targeted, and under that 13 sectors, 1300 companies were given these specific targets to perform. So let us talk in terms of data now. Here is that so what was done under that, under PET cycle 1 was that number of designated customers were about under various sectors. The data I am showing you is for 478 customers. So for each major industry, be it aluminum, cement, alkali, fertilizer industry, iron and steel, pulp and paper, textile, thermal power plant, all the major industries were given separate targets. So they were given a target of reducing MTOE in absolute terms. And while the growth was there, so it was the growth was delinked to energy performance improvement. So they were given specific targets, and so overall the targets was about 6.6 MTOE, which was given as a target to all the industries put together. And what was achieved in the first phase of the PET 1 was the performance was better than which was targeted. So against the target of 6.68 MTOE, what industry could achieve at a cumulative level was 8.6 MTOE. So performance was better than what was targeted overall. And if you look at all the industries kind of did well. So they kind of overachieved of target. So all of them kind of overachieved, with pulp and paper doing probably the best, that their overachievement was almost 144% compared to what was given as a target to them. However, as I said earlier, if you would have looked at this picture in aggregated way, we would have said that all sectors did exceedingly well, all sectors did better than what was targeted, given as a target to them. And that's where the things comes into picture, that if then once you start looking data into subsectorial wise, that's where you look into that thermal power plants actually did not meet the target, because they did less than the given target. They were negative by 4.7%, and since they were the sector with the highest kind of a target which was given to them, so impact on overall achievement, the kind of everything was pulled down by them in terms of what was achieved at that level. So I think this number is slightly wrong. I'll correct this number, but overall what you can see is that India did better than what was given as a target to it by industries, did better than the target given to them. But however, as you can see that across industries there were variation in terms of achievement which was done against the given target, but India did overall okay. There are critics around it, there are researchers around it, that the targets were too little for the size of industry that they were, and the industry should have really talked in terms of percentages rather than talking in terms of absolute number, because the absolute number doesn't tell you at all in terms of the actual consumption of these industries, and what is actual achievement potential versus what was achieved under this scheme is something again which is hidden here. Anyway, this is one attempt which India did around this energy intensity side or energy efficiency side. This is more on energy efficiency side, and India has seen success, but could this have been better is something which has been debated a lot in the research community. We will continue from here going forward, and then we will start looking deeper into understanding the difference between the energy intensity and energy efficiency side, and then what are the other effects of this all of this change which people are targeting to achieve. Thank you.